Okay, so today we're going deep into a topic that I think really stretches the limits of what most people can even imagine.
Yeah.
String theory.
It's pretty out there.
It is. And this whole deep dive is inspired by a conversation that I was watching between the great Brian Greene
Oh, yeah.
and Alex O'Connor on the Cosmic Skeptic YouTube channel.
Awesome channel.
It is a great channel.
Huge fan.
Yeah.
Love Alex O'Connor.
And it was actually to mark the 25th anniversary of Greene's book, The Elegant Universe.
Oh, wow. Yeah.
Which
That's a classic.
it is a classic, and it feels like the perfect moment to really dig into what string theory is all about, why it continues to be so important in physics today,
Absolutely.
and why it matters for, people who are interested in learning about this stuff.
Yeah.
So our goal here is really just to build some kind of foundation
Okay.
for understanding string theory and why it matters and some of the implications that come out of it.
Right. And to really get to the heart of why string theory is so important, you kind of have to start with this dream that physicists have had for a long time, and Einstein was really passionate about this.
Oh, really?
The dream of a single mathematical framework that could explain everything in the universe.
So like a theory of everything?
Yeah, a theory of everything that could take you from the tiniest particles all the way up to, huge structures like galaxies.
So like the smallest stuff and the biggest stuff all explained by one idea.
Exactly.
That's a pretty big goal.
It's huge, and it's been driving a lot of research.
I mean, for decades now, physicists have been working with these two like really successful but seemingly incompatible
Right.
descriptions of reality.
Yeah.
So on the one hand, we've got quantum mechanics, which describes, like you said, the really small stuff.
Atoms and quarks, all that.
Yeah, like the real building blocks. And then on the other hand, we've got general relativity,
Right.
which is equally elegant. I mean, it explains things like gravity,
Yeah. Planets, stars, black holes.
the big stuff.
Yeah.
And so it's like, okay, we've got these two things that work really well,
Right.
but the big challenge is trying to combine those two.
Exactly. And that's where things start to get really tricky, because when you try to combine them mathematically, especially in places where both are really important, like at the center of a black hole
Right.
or the very beginning of the universe, the math just breaks down.
It doesn't work.
It doesn't work.
Yeah.
You get these infinities, these nonsensical answers. And as Brian Greene points out, infinity in physics, it's not some profound insight. It's a sign that your theory is broken.
Like it's a red flag.
It's a huge red flag.
It's like trying to divide by zero in your calculator.
Yeah, exactly. The
Hey.
math just falls apart.
So that's where string theory comes in. Right?
Exactly. String theory comes in as this attempt to solve that problem, to try and find a way to combine quantum mechanics and general relativity without getting those crazy infinity,
Without breaking the math.
without breaking the math. And the way it does that is by making a really fundamental change in how we think about particles.
Okay. I'm intrigued.
So instead of thinking of particles like electrons and quarks as these tiny little points,
Right, like infinitely small dots.
yeah, infinitely small dots, string theory says, no, they're not points. They're actually tiny little vibrating strings.
They're like little tiny filaments of energy.
Yeah, like tiny little strands of energy that are vibrating.
And that's the big idea.
That's the big idea. And it has some really mind-blowing consequences.
Okay, so walk me through this.
So think about it like a musical instrument, which is an analogy that Greene uses really well.
I love a good analogy.
These strings, they can vibrate in different ways, right? Different patterns, different frequencies. And each of those vibrations corresponds to a different particle.
So like a different note on a guitar string is a different particle.
Exactly. So the universe isn't just a random collection of particles. It's like this giant cosmic symphony.
So all the different particles and forces we see
Are just different notes being played on these tiny strings.
Wow, that's a pretty beautiful way to think about it.
It's a really elegant way to think about it. And it suggests that there's this underlying simplicity to the universe.
That's really cool. I mean, thinking about the entire universe as this cosmic symphony played on these tiny little strings,
Yeah.
it really makes you rethink what reality might actually be like at the most fundamental level.
Absolutely.
And one thing that Greene talks about that I found really interesting is that he doesn't think our older theories like Newtonian gravity are necessarily wrong.
Right.
It's more that they apply to specific situations and scales, right?
Exactly. Like Newtonian gravity still works really well for describing how planets move in our solar system.
It's good enough for what we use it for.
Yeah, it's super accurate for that. And then Einstein's theory of relativity came along and gave us an even more accurate picture, especially when you're dealing with really strong gravity or really high speeds.
Right.
But the point is that these theories, they're not wrong. They just work really well within their specific domains.
So it's kind of like having different tools for different jobs.
Yeah,
Uh,
exactly. Like you wouldn't use a hammer to screw in a screw.
Right. You need the right tool for the job.
Exactly. And string theory is like this more advanced tool that lets us explore these really extreme parts of the universe,
Where the other tools break down.
where the other tools break down like the very beginning of the universe or the center of a black hole.
Now, Alex O'Connor brought up this interesting point about some resistance to string theory in the physics community.
Yeah, there's definitely some pushback.
Do you think that's because physicists are maybe a little attached to these older theories that have been so successful?
I think that's part of it. I mean, it's natural to be hesitant to move away from something that's worked so well for so long.
It's like a comfortable pair of shoes.
Yeah, exactly. But at the same time, there's also this drive in science to keep pushing forward to find that next big breakthrough.
Right.
And string theory, it's got this potential to solve some really big problems and open up whole new areas of research.
And it's all based on this really elegant mathematical framework.
Exactly. The math is really solid.
So let's go back to this idea of strings for a second.
Okay.
It's a pretty big change from the way we've always thought about particles as these tiny little points.
It's a radical shift.
And Greene talks about how moving from a zero-dimensional point to a one-dimensional string
Right.
actually helps resolve those mathematical conflicts between quantum mechanics and general relativity.
It does. And it's kind of amazing how something that seems so simple can have such a huge impact.
So how does that work?
Well, when you think about particles as points,
Mm-hmm.
their interactions are like these infinitely small points in space.
Right.
And that's what causes those infinities in the math when you try to combine quantum mechanics and gravity.
It's like the math is trying to cram too much information into a single point.
Exactly. But if you think about particles as strings, then their interactions are spread out over this tiny but not infinitely small area.
So it's not a point, it's like a little blur.
Yeah, it's like a little blur, and that smearing out of the interaction actually gets rid of those infinities in the math.
So the math doesn't break down anymore.
Exactly. It becomes consistent.
So instead of this tiny dot, an electron is actually this little vibrating loop or filament.
Yeah.
And the way it vibrates determines its properties, like its charge and mass.
Right.
And all the other particles, like photons and quarks and neutrinos, there's just different vibrational modes of these strings.
Yeah, that's the idea.
So like Greene says, the universe at its most basic level is this incredibly complex, microscopic musical composition.
And physics is the study of that music.
And the strings are the instruments.
Yeah, that's a beautiful way to put it.
But then, of course, the big question is, if this theory is so elegant and so unifying, why haven't we actually proven it yet?
Yeah, that's the million-dollar question.
It's the elephant in the room, right?
It is. And Greene addresses that head on. He acknowledges that it's really difficult to test string theory experimentally.
Yeah, I mean, it's not like Einstein's theory of relativity where we could just wait for a solar eclipse and see if light bends around the sun.
Right, that was a relatively easy test.
It's relatively easy,
Yeah. But string theory, it's a whole different ballgame.
And so a lot of people are probably thinking, if we can't test it, why should we even care about string theory?
Right, why bother?
And the main reason it's so hard to test is because these strings are thought to be unbelievably tiny.
Unbelievably tiny.
Like way smaller than anything we can currently see with our most powerful microscope.
Yeah, orders of magnitude smaller.
So to actually see these strings, we would need particle accelerators that are so powerful.
Well, you have to be huge, maybe even bigger than our galaxy.
Bigger than the galaxy. I mean, that's just not feasible.
Not with our current technology.
Yeah, anytime soon.
Not anytime soon. But the important thing to remember is that just because we can't test it yet doesn't mean it's not scientific. Greene's really clear about that.
Right. He's not saying we should just accept it on faith.
No, he's saying that good science starts with a hypothesis. And often that hypothesis is expressed mathematically.
Right. And the experiments, they can come later, sometimes much later.
Yeah, especially when you're dealing with things that are so small and so fundamental.
So it's not that string theory doesn't make any testable predictions.
Right. It does make predictions about things like new particles
Right.
and how particles interact at really high energies.
But we just don't have the technology yet to actually test those predictions.
Exactly. We need to build better tools.
So it's like we have this blueprint for how the universe works at the most basic level.
Yeah, a really detailed blueprint.
But we don't have the magnifying glass powerful enough to actually see if the blueprint matches reality.
That's a great analogy.
So it's really a long-term investment in understanding the universe.
It is, and it's driven by the beauty of the mathematics and the hope that someday we'll be able to test it.
And maybe even prove it right.
Maybe even prove it right.
So to sum up for our listeners, Here are the key takeaways from our deep dive into string theory,
Okay.
inspired by Brian Greene.
Right.
First, string theory says that the fundamental building blocks of the universe aren't these point-like particles.
But tiny vibrating strings.
Right.
Second, it's an attempt to bring together quantum mechanics and general relativity.
Which are currently at odds with each other.
Yeah. Third, older theories like Newtonian gravity and Einstein's relativity, they're not wrong.
Right. They still work within their specific domains.
But string theory aims to go beyond those domains.
To a more fundamental level.
Fourth, string theory is mathematically elegant and consistent.
But we haven't been able to directly verify it experimentally yet.
Because it requires technology that we just don't have.
Yeah.
And finally, even though we can't test it right now, string theory is still a really important area of research.
It has the potential to revolutionize our understanding of the universe.
It's a big deal.
It's a huge deal.
So I want to leave our listeners with a thought to chew on.
Okay.
If the universe is like this cosmic symphony played on these tiny vibrating strings,
Right.
what could we learn about the nature of reality by studying the different instruments and the melodies they create?
Even if we can't hear those melodies directly yet.
It's a pretty mind-blowing idea. It is, and it really highlights the power of human curiosity and the quest to understand the universe at its deepest level.
It's a journey that's still unfolding.
And who knows what amazing discoveries await us.
That's string theory for you folks.
A cosmic symphony in the making.
Thanks for joining us on this deep dive.
It's been a pleasure.
We'll see you next time.
See you then.